Welcome to Finite State Machines CS AQA theory. We're going to be going over what finite state machines are and how it is used in today's revision video, and that is what we're going to be doing today. So what's going to be covered? We're going to be able to how you create a state transition diagram, what an accepting state is, finite state machine in regular languages, finite state machines and output. That's all that we're going to be covering today. So active recall, pause this video, see what you can remember, and write it down as much as you can about finite state machines. See what core things you have in your head. And if you don't have anything, don't worry, we'll go on to the next bit now. So pause the video, and now I'm going to go to the next bit. So some key notes. A finite state machine, as a definition, is an abstract model of computation to model logic. So here's some basic things you got to know. S0, S1, and S2. S0 is switched off. S1 is on and moving forward. S2 is on and moving backwards. So this is like sort of the generalization of different states. Now, to transfer different things to get to different states, you can have a push button and stuff like that. So that's just what a basic thing of all the states is. So next up you have a button, push, a sensor, all of which can get towards different states and stuff like this. So S0, you do a button push, you get to S1, then you take the sensor and you get to S2. Another sensor, you go back to S1 and then you go forward to S2 again. Or another button push, turn it off, you go back to S0 and stuff like that. So that's just a basic diagram, but don't worry, you won't have to identify this in the exam. Instead, you have to do something a little bit like this. So for example, you'd have a 5p. So this is a vending machine that we'd have to use, and obviously you would have to get towards this little one here. Now an accepting state, that's this one here, circles like this, you're definitely going to need to know that. An accepting state needs a criteria that needs to be reached, and it may not be reached, and that will be an invalid string. So for example, you've got 5p, 10p gets you to the accepting state. Or you can have 5p, 10p, 5p that gets you to the accepting state. You can only here have 5p, 10p and 20p in your finite state machine. You have to have all of these different ones to create your finite state machine or get it. So you can't have 50p because for whatever item you need, it has to always equal 20p. So for example, if you put 5p in here and then 20p, that's 25p, it gets refunded out. You've got to think about it logically. It's a vending machine. You can only put in max 20p. You put more than that, it all gets pushed out and goes back to S0, and that turns the whole thing off. So just kind of need that basic knowledge of how a finite state machine works. It's fairly straightforward, I would think, but just get from S0 to S1, S2 to S3, there's lots of different ways, and you've definitely got to be able to follow it. So from here, S0 to 5p, like that. But that's not how you usually do it in an exam. In an exam, it's something more like this. So a measly machine. So this is FSM with outputs and stuff like that. I think I've kind of disregarded some stuff. So maybe we'll look at some of Isaac computer science. So for example, this one. This is more like you're going to be using in an exam. You've got to follow it down to a T. So which one should we take? We'll take this one here, right? This is the for one. I'm using Isaac Computer Science, by the way. If you want to go check it out, it's a really good resource, and that's what I use for most of my revision, and that's why I'm using it here. The link will be down below. So S0, if you're going to use the 5p input, it's going to go to S1. The 10p input is going to go to S2. 20p input is going to go to S4, and so on and so forth. There's no 50p inputs, but that's what you get. So if you go here, S0, go to S1, S2 and S4, and S4 is the accepting state. S1 and it will be 5p, 10p and 20p too. So you just got to know that. It's fairly easy to know, I would say. Just being able to follow it and write it into a state transition diagram could easily push you up that many more marks in the actual exam. So obviously in this one, I'll just go back to presenting it. It's fairly straightforward. So moving on to probably the harder stuff, FSM with output. So this is a meaning machine. It's determined by an output and a state. So for example, you've got 0, 0 here. This is the state and output like so. So for example, this will stay there. If you got 1 1, it'll go to S1. 1 0, stay at S1. 0 1, stay at S1. Now, just looking at this, because this explains it in a much better detail, please go check this out. I am not a genius. So this is a transition. That's what the arrow is. Transition. So this is what I was talking about here. So when the first one is found, it is left as it is. So for example, this is the first one here. So you get a 0 first, goes back around, then you find the 1 here, and then that gets cut off. So that first 0 goes, and you get 1 0 1 1 0 0. So that is fairly straightforward, I would say. So in a transition state, you've got 0 0. You stay as it is, like the input, the output, it stays at S0. You've got 1 1, goes to S1. You've got 0 1, stays at S1. 1 0 stays at S1. Fairly straightforward stuff to understand, guys. I think that any questions below I'll answer, but when you presented with a finite state machine that says here where the states are numbered instead of described, you might find it helpful to articulate a description for each state. So I would say it's very easy to understand, and I hope that helps. So let's go through some exam questions. Now I know it's quite old, but this will still help you at any point. So you've got S1 here. So S1 here, right? You put in 0. That goes to S2, as we can see that. S1 1, that goes to S3. S2, you put in a 0, that goes to S2. You put in a 1, that goes to S4, and obviously that is what we call the remembering state or the acceptance state, whatever you want to call it. That is what that is. So that's fairly straightforward. So what have we got to do? We've got S4 here. So you've got to just put in the 0 1 for each different state. So S4 0 stays at S4. S4 1 goes to S5. S5 0 stays at S5. S5 1 goes back to S4. So that's what it is. And for this to be like not an invalid string, it has to end up as the acceptance state. Now we know what an acceptance state is. That's a double circle there, and that's already 2 marks in your test. So moving on then, write yes or no in each row of the table below to indicate wherever or not each of the 4 input strings will be accepted. Now, to be accepted, it has to reach the active or remembrance state, or whatever you want to call it. I usually call it the remembrance state. I don't know if that's the correct term. Just remember how you want to say it. So 1 0 1. So 1 goes 0 or 1. So we're stuck at S3. So that's a no. Okay, that is a no. 0 0 0. 0 0 0 stays at S2. Again, that would not be accepted. That's a no. So this one's a bit longer. So we've got a 0 1 0 0 0 1 1 0 1. Now, I'm probably going to find this quite hard to remember myself without having it in front of me, like you guys. So, but we'll just do this. So 0 1 gets us to S4 already. So that's 0 1. Then we've got 3 zeros in a row that keeps us at S4. Then we've got another 1 here, another 1 there, takes us back to S4. And then we've got another 0, and then we've got a 1. So again, that one would not be accepted if I've got it right. I might have got it wrong. Double check for me, because I don't have it like on the page for myself. But yeah, obviously I'm not an expert, but I'm trying to do this as best as I can. So the next one is even longer still, but as you can see here, you just take it. It's exactly the same as the other one we have previously done. Now these are good things to note in exams. I would say once you could easily like not cheat the system, but if you notice like, so you know the third one's incorrect, you can save a bit of time here and find out, because obviously we ended up at S5 in the third one, so one more would take us to S4. So that is all fairly straightforward here, isn't it? So this is 4D, you've got some of this stuff. What is this? Oh, this is just you putting it towards the end. They will always transition the states that are currently unlabeled. The machine should work for 4 binary patterns: 0 0 0 1 1 0 and 1 1. So I think this is obviously pretty straightforward. You go 0, then you go 0 there, 0 1. So obviously it'll be 1 0 and 1 1 for both of these, and that equates to 4 volts and 6 volts there. So again, very straightforward to understand. June 2016, so maybe a more recent one. They've got some X's in. Now I know you're all like, oh my god, what do the X's mean? How do I use the X's? You use the X's like you would any normal thing. Just follow it along, very fine. So we've got 3 1s first. So 3 1s will keep us at S1 for the whole time. and then we've got 0, 1, 1. So it'll go 0, 1, and then stay at S4, and then we have got an X, I think. So that one would be accepted. S3 will be accepted. Now guys, these are all on Physics Maths Tutor, AQA, Computer Science. Again, another link in there if you want to go check the answers, or you think I got anything wrong. Do tell me. I'm learning just like you guys. I'm just trying to talk on here, see if I can make sense of it. 1110, 1110, so that's 3 1s again, 0, and then an X that takes you straight towards S3. So that's obviously a yes. So you write yes here, and then you've got 111, so we know that's S1 already, 0 0, so 0 0, takes you back to S4, and then you've got 1, and then you've got an X. So that one would not be accepted there, guys. Okay, and then I think these all are pretty similar to each other. 2017 is a little bit harder maybe, and I'm not actually going to do this one. It'll take quite a while for me to do, but again, it's quite easy. You just got to go backwards and state the different parts of it. So you've got to label A to H all the different events that have come here. So door code, open, no code, and then that links back to there. So for example, the first one is to close the safety lock, push the door shut. So door open, no code, door shut, no code. You've got to label the first one. So the first one here would be door pulled open, I think, and then stuff like that. So just straightforward things to do. It's very, very easy to understand. And then you've got some more harder ones here. So like this is a very long question. So like if the FSM in figure 3 reaches state 12, what does it mean? And stuff like this. So state 12 is all the way down here. I actually just want to double check that answer. Oh, that isn't. Is this that? No, this is not the right thing. I'll just do that. Repeat this, and then look at this one. So, looking down here, final state month scheme. Just double checking what the postbox one would be. So 2.1. We have got input string. Is a valid postcode, so postcode has additional characters at the end, so that's fairly straightforward. I didn't realise there'd be such a question like it is, and yeah, so state 12, just any character, so that should be pretty obvious to you guys. So yeah, this is just a basic sum up of finite state machines. Hopefully you found the questions easy. I used to find it not challenging. I had a pretty, not incompetent teacher, but I just didn't really pay attention in year 12. So I understand why people can struggle on this stuff, and I guess I'm not the best, but I think this is a very straightforward area to learn. So yeah, thank you guys for watching.